Hello students, welcome to my channel Physics with Rams. So today we are going to discuss about the new chapter verse, and until now we had covered almost all the topics which are in first year. As I had taken some time in order to make the video, sorry for that. L- Before going to start this video, I would like to say something that analyzing by analyzing itself you can learn the physics, and if you can analyze the subject then you can crack neat as well as mains easily. So while reading or while listening the videos, don't forget to analyze. By analyzing itself you can understand the physics in a very easy way. Let's start the topic. So in this video we are going to discuss about waves. So what is a wave? Means a wave is nothing but a disturbance created in a medium. So generally when we consider mechanics, in the case of mechanics, we just represent that by the movement of body. Here the energy as well as momentum is being transferred. Energy and momentum is being transferred, whereas in the case of waves we represent the transfer of momentum as well as energy without the movement of particles. So here what happens when a wave is being generated within a medium, here energy as well as momentum is being transferred. Momentum is being transferred without the movement of particles does not change their position, and they remain at the rest position itself. So when I consider a wave, these waves are called as mechanical waves. These waves are called as mechanical waves. Other than mechanical waves, we have different types of waves, just like electromagnetic wave, as well as matter waves. Mechanical waves are the waves which require medium in order to propagate from one place to another place, whereas electromagnetic waves are the waves which does not require a medium, just like sunlight. And the example for mechanical waves is a sound wave. And matter waves. Matter waves are the waves which transport from one place to another place due to the movement of matter, just like protons, electrons, nucleons, like this, neutrons. So due to the movement of particles, the waves are being transmitted from one place to another place. Remember that if a wave is being propagated, means energy is being transmitted from one end to another end, which is given by us. It's called as a wave. And when the energy is being transported from one place to another place, here what happens, distance will be created within the medium. That's why it's being propagated from one point to another point. So now we are going to discuss about mechanical waves in this topic. When I consider a mechanical wave, based on the nature, it's being classified into two types. The first one is a progressive wave, and the second one is a stationary wave. Again, this progressive wave is being classified into two types. One is longitudinal progressive wave, and the second one is transverse progressive wave. So, what is meant by progressive wave? Means a wave which propagates in the forward direction and never return back is known as a progressive wave. Whereas when I consider a stationary wave, a wave which propagates in the forward direction, after hitting any rigid support, it returns back to the same point, which is represented as a stationary wave. Stationary wave. Come to the case of these progressives, as we had represented a longitudinal and transverse. Longitudinal progressive wave will move in the form of compressions and rarefactions. Just like a compression of a spring and rarefying of spring, expansion of the spring, and again compression of the spring as well as expansion of the spring, like this. In this way, here the wave is being propagated from one point to another point. We represent the compression, it's being represented like this. It's a compression as well as it's a rarefaction. Again compression and rarefaction. Remember that the particles within the medium will not change their position. Why? Because they have high elasticity, elastic nature, as well as they have high inertia. They have high inertia as well as elasticity. Whereas this transverse wave, they propagate from one point to another point in the form of a crust as well as a trough. Crust and trough. So as we observe that the vibration of the particles, they are not going to change their position, whereas they vibrate at that place itself. The vibration of the particle is along the propagation. Observe that the wave is moving along this direction and the vibration is also along the same direction in the case of a longitudinal. Whereas in the case of transverse, observe that the vibration is perpendicular to the propagation. It's perpendicular to the propagation. So remember that in the case of longitudinal waves, the vibration of the particle will be along the propagation, whereas in the case of transverse, the vibration will be perpendicular to the propagation of the wave. And one more point regarding this longitudinal waves is that these longitudinal waves can be propagated in solids, liquids, as well as gases. Whereas the transverse waves cannot be propagated in liquids as well as gases. Why? Because they don't have a rigidity modulus. Since a bulk modulus is being considered, we represent that the transverse wave can be propagated along the solids as well as on the surface of liquids. Surface of a liquid. Since the liquids as well as gases does not possess the shear strain, we consider that the transverse waves can be propagated only on the solids as well as the surface of liquids. These are the major differences between longitudinal and transverse waves. Now, based on that, we are going to discuss about some basic definitions which are useful to us throughout this chapter. The first one is wavelength. It's being represented with a lambda, and wavelength is nothing but the length of a complete wave, propagated wave. It's known as a wavelength, or we can also represent as the distance between two successive crusts, or the distance between two successive troughs. The distance between two successive troughs, or a distance between two successive crusts, is known as wavelength, and it is being measured in terms of meters, or the smaller unit is Armstrong, or we can also represent it in terms of nanometers. We know that 1 Armstrong is equals to 10 to the power of minus 10 meter. Similarly, we are going to represent a time period, whereas the time period it's being represented with a t. So time period is nothing but the time taken by one complete wave. It's known as time period. A wave is nothing but it's a combination of crust and trough. So the time taken by complete wave is known as time period, and its unit is a second. And the next one is frequency. Frequency, it's being represented with f, whereas frequency is nothing but number of vibrations in 1 second, or number of oscillations in 1 second. It represents frequency, and the relation between frequency and the time period is f is equals 1 by t. Number of oscillations or vibrations by time, that represents frequency, whereas the unit for frequency is hertz. Frequency is hertz. Similarly, we represent a wave velocity. Wave velocity. Velocity possessed by the wave is known as a wave velocity, and we know that velocity is equals to displacement, nothing but a wavelength, lambda by time taken by the wave, nothing but a t. Where we had observed that 1 by t is equals to f, we can represent it as lambda into f. So the unit for velocity is meter per second. So here we are going to represent the velocity possessed by the wave. Let's solve a problem based on this wave velocity. Observe that velocity of a wave in gas is represented as 35 meter per second. Then the wavelength of the wave when it possesses a time period of time period of 10 microseconds is. So observe that the time period has been given as 10 microseconds, so we can represent it as 10 into 10 to the power of minus 6 seconds, or we can also represent it as 10 to the power of minus seconds. And here the velocity has been given as 35 meter per second. Here we have to find out the wavelength of the wave. As we had seen, lambda v is equals to lambda by t. then lambda is equals to v into t. So when we substitute 35 into 10 to the power of minus 5, nothing but 35 into or 0.35 into 10 to the power of minus 3. So we can represent it as a 0.35 millimeter is the wavelength of the wave. So thank you for watching my video. Please like, share and subscribe my channel. Don't forget to watch my videos regularly, and I will post my videos regularly from now onwards. Thank you.